So hello everyone. We'll start our last session of the day. So I will just give a brief introduction about our speaker. She is Dr. Shivani Sharma, who is working as a principal technical consultant at Hitachi Energy, Faridabad, India. She is having 15 years of professional experience with different advanced technical solution in power system analysis, R&D trainings, design engineering for conventional as well as feasibility of microgrid, e-mobility, DER integration, and many more. She has also worked with Reliance Industries Limited and Samsung Energy India Limited. Her PhD is in electricity regulations, renewables, data mining, and master was in electrical power system from Sardar Patel University, Gujarat. Her area of interest are in futuristic technology, R&D, smart grid transition, renewable integration, and EVs, data mining, and more. She has contributed more than 40 technical and research publications, which are presented in national and international conferences and events. Today, she is going to deliver a lecture on enhanced digitization and big data integration aspects for energy security. So now I would like to invite Shivani ma'am to please take the session, and I hope all the participants will get a very good practical exposure as she is working with the industry. Up to you, madam.
Thanks a lot, Jugal, for that nice introduction.
Thanks, ma'am.
And a very, very good afternoon to all the participants. And I think it's a challenge to, take the last session and maybe the post lunch one. So I just hope that we have a interesting discussion and go ahead with this. And first of all, my best wishes to RSU for this FDP on a very, very relevant topic, which is really very important in today's times. And thanks for this opportunity. I would just go ahead and share my screen. So, Jugal, if you could just confirm that you're able to
Sure.
see my screen.
Uh, yeah, I will confirm. You can share the screen.
Yes, so I've started sharing it. Is it
It's not visible yet.
okay? I think it's
Yeah.
on in the way
Yes.
now.
Yes.
Okay,
Yeah, ma'am.
all right. Okay. Fine. So today we'll be talking on enhanced digitization and what's the big data integration aspects for energy security. And this, dear participants, I think this is one of the most important and significant aspect when we are talking of India as a developing nation. We have so many of technologies, be it in the electrical sector, the IT sector. There's so much data that we have all around, but the energy security and how really we are utilizing that big quantum of data to make it intelligent and to make it really useful is something that's very important in today's times. And just to give you a brief, I work in power consulting, and we work on a lot of assignments which are related to the existing kind of technologies that we have, or the futuristic technologies that would come over. And in fact, this brings me to my mind that while I and Jugal were discussing that, what areas we should be capturing for this particular session. So there are also a lot of R&D projects that we are working on. And if I talk of, an application which is a little bit related to power systems, but the way IT and big data, it has entered each and every aspect of our industries. So I would quickly give you example of few R&D projects that we are presently working on. So there are the complete power grid. You may have heard of the transmission, generation, distribution utilities. And there are so many new players as well. So we are, when we talk of electricity, it's no more coal power plant. You hear of renewable, you hear of e-mobility and all such things. So when we come to these new players, there are more and more points that we are adding into the system, more data points, more field measurements, and then handling this complete data. And it has, as we advance, as all of you would have heard that, recently our prime minister, he participated in the climate change conference COP 26 in Glasgow. and he has defined our goal of carbon neutrality by 2070. So once such kinds of goals are defined as a nation, there's a lot of background work also that goes behind this. And in fact, in October, we had a press conference where, it was a debate that what India is actually going to declare, because, the other countries, if you talk of China, they had mentioned a specific year and now they'll be doing it 10 years later. There are also a lot of debates which went on that all other nations are developed nations, we are developing nation, should we really be given such a tough target or not? But the way it is defined, and it's very important that when we talk of high level advanced cyber security systems, it is so important that as we bring in more and more data, the way we are handling it has also to be very very careful. It has to have a lot of insights. And today I bring to you the, I would say, the big data aspect or the enhanced energy security aspect as far as the energy network, the smart grids are concerned. So I'm sure that by end of the session we would have a good idea on how this big data applications play a very critical role in the complete handling of different industries. And if you look at electricity, it's one of the, it is famously called the backbone of the complete industry system. Since anything is dependent on electricity, even all of your academic institutes, your data centers, etc., they all run on electricity. So of course the security of this energy, the security of the cyber system, and the application of big data, on how we are really applying it and trying to balance the out systems, that too in live networks. So along with these new technologies, we work on a lot of live projects which are there. And as I was mentioning, I'm also part of the global team, and we work on a lot of R&D projects. So we do take actual systems, we take actual site measurements. So just to give you a very small example, there's a complete utility in Singapore for which we are doing the site measurements. So as in, going to each of the feeders, each of the measuring all the important parameters. So it could be the voltage, the current, the harmonic, the current distortion, voltage distortion, interharmonics, etc. A lot of parameters that we have, and measuring that what that site measurement level is as on date. So what is that actual big data that we have? So there are thousands and thousands of reading which we get, and typically they are in a format which we then take into a software which would be typically related to a smart meter. And then having those thousands and thousands of or say lakhs of data values, and how do we process it? So like you have your IT systems, your cybersecurity systems. Similarly, we have different elements. So for example, you would always know that there's a power cut, there is a short circuit which occurred, or there's a transformer which got burnt out, or something tripped, something went off. So that is basically a relay operating. Whenever there is a fault, a relay would operate. So the complete algorithms of these major and critical power system equipments, we also work on those algorithms. So once you have those algorithms, how do you really go into that batch processing mode, and how do you make those algorithms more intelligent? Because there have been the conventional systems right in the system through long, the way they behave. So if you talk of a thermal power plant, it will behave in a certain way because it has inertia into it. The If you go back to your basics of mechanical, so it would have a lot of inertia, and the way the fault currents it would contribute, it is very very different when you compare it with new sources like renewables, etc. So this is one area where we are looking for a lot of innovation, a lot of research and developmental projects. So going further, if I'm sure being eminent faculty members, you would be involved in a lot of research and also getting it done from your students. So it would be my humble suggestion that energy security is one place where we are looking for a lot of advanced applications of big data of IT systems. So you could definitely consider it into your research works. And when we talk of batch data, when we talk of algorithms, they are live system where we really try to understand what's the background logic which takes place. Of course, then again there are detailed power system analysis which we try to enact along with it. And how the algorithm is performing, is it faster than the existing systems, and what's the exact requirements. And if you see that the regulations, the important stakeholders, even the government is revising a lot of uh, I would say policies which are related to the integration of these systems. So the complete way this is to be taken is again very very important for all of us to see. And this of course is a very small one of my favorite thoughts, which says that what we have completed would demonstrate what we know, and the future projects would decide that what we are going to learn. So this was just a sort of a warm up or a brain opener for all of us on what the discussion is going to be about. And if I talk to you of the agenda in very brief, I would be talking of the digitization of power value chain. And friends, this digitization is the very very new technology, I would say, or the one thing, digitization, which would cover each and every aspect. So I'm aware of you working into advanced IT systems, it would be something very common for you. But if you talk of different industries, if you talk of different segments around, digitization is one thing which is entering each and every aspect of all the systems you see around, be it industry, be it utilities, be it your academic institutes, etc. So everything is moving towards digitization. And here we see the actual established aspect of big data, the requirement of handling it very well, and then trying to take out useful outputs, useful trends that we would be incorporating in future. Energy security and resilience is the another one. So you must have heard about a lot of cyber attacks. Similarly, there are also blackouts which occur, and these are very closely interrelated to each other. So when we talk of energy security, it is really related to the kind of power supply that you are getting at all places, but at the same time what kind of technologies you are using. And at the same time, the blackout could be due to a cyber attack and vice versa. You really need all your servers or your data centers to work up to date. In case you have a blackout of electricity, it's really going to have a break into your system or disturb the complete operation of it. So that's where energy security and resilience is something which is very very important. And resilience, if we say in simple terms, it is something like a self healing feature. So in case you feel something is going to go wrong, you have a predictive system, or I would say a proactive system, where you are trying to correct the things even before something goes wrong. So for example, even before a fault occurs, we could say measure the parameters, you could predict whether there's a fault which could possibly occur, and how could we clear it out. And then when we talk of new technology, of course, there is a lot that we are doing. Even if you are aware, as India, we have defined our targets that by 2022, we are moving to 175 gigawatt of renewables. By 2030, we would be somewhere in the range of 400 gigawatt, and so on. So once we have all these new technologies, we are also working on different combinations on what could be the perfect thing when we talk of critical infrastructure. And that would include your data center, which is a very very specific example. And this, I hope, it should really provoke you to see around, look around you, that in your own academic institutes, what is that IT system, of course, that you have, but also what's the energy security that you have around, what are the kind of power sources that you have. And maybe somebody from the electrical department is going to come and tell you that we are getting a microgrid, we are having a solar rooftop, and to meet the carbon neutrality standards, these are our new power sources. And of course, as a owner or as an important stakeholder for your complete control system or the data center, you really have to look down into these aspects to see that things don't go wrong. And also, when we say things don't go wrong, of course, cyber attack is one of them. But also, as you see the climate change aspect, you would see more change on the renewables due to the new climate change, or say you suddenly get a cloud, your solar gets affected, you have substations flooding, you have forest fires, etc. And this is something very serious because if you see a few months back, there was a blackout in Texas where the temperatures dropped really down, and there was freezing of the gas pipelines, and there was a blackout. Now, when such blackout occurs, what happens to your cyber security systems becomes very, very important. And then we would briefly also talk on big data, the applications and the analysis. And here, of course, a typical example and the way you could also implement the complete thing, like whenever you talk of anything, it may be a cyber crime, it may be detection techniques, it may be making anything better. So that's where there's an important application of big data and the analysis. And just to mention, this is a very small example where in 2012, almost for 2 consecutive days, 30 and 31st July 2012, there was a complete blackout in India, and majority of the zones were disconnected. Of course, Gujarat had isolated itself, the western region, and we were lucky enough that our systems kept running and we were not impacted. And there was a special committee also which had tried to investigate in detail, like why this happened, what went wrong. And in that committee report, it was also written that thankfully we did not have a cyber attack, but what are those special schemes that we need to incorporate so that such cyber attacks or any other attack shouldn't be occurring in the future. And that's a very interesting report which shares many action points, and I'm sure few of you may also be related to those committees or how it's going ahead. And just to give you a brief glimpse on how the complete power grid is changing, it gives a very small example that first you had a very conventional power value chain of generation, transmission and distribution. But now you would see that your academic institutes, you would have a solar rooftop, you could say have a battery system and so on. So it's all the complete new kind of players that we have around. And when we talk of the pioneering and the digitization aspect, there are products, there are components which are changing everywhere worldwide. So you would have different options available. In fact, if you talk of the carbon neutrality aspect that I just mentioned, so there are now new products which are available from the switchgear point of view, which say for example you may have a LV switchgear which is more helping the carbon neutrality. It would use less of SF6 gas, which is a major pollutant, and so on. So there are a lot of the components, I would say, the end of the power value chain, the software and automation. So here it is more about the deepest application or know-how. So it's a good terminology in industries that we use, that from field to the boardroom. So now all the senior management, they all like to have those dashboards on right in front of their cabin. So there are all these important data, the live data streaming out of the industry or the processes or the organizations that you talk about, and those dashboards are very relevant and help in taking the correct decisions to all the management. So whatever happens in field, you define the logics, you see what data exactly you would like to see and what's critical for you to take further actions. And of course then you have different systems, different services. And even if you talk of a operation maintenance, it's no more the conventional one. We have digitization there also. We have the 3D systems, we have the visual reality, the artificial intelligence applications, where they could be a site in Sweden, but an O&M expert sitting in India, he could wear that special device, he could help the other person navigate to that particular equipment and then give live assistance, which previously it was not possible. A person had to practically travel, and the site personnel had to wait for a specific amount of time before he got the solution. Also, there are factory acceptance tests which are done remotely now thanks to the digitization aspect. And of course, the different solutions, the O&M solutions, we'll have a look at it in a brief as we go ahead. And there are a lot of, I would say, there's a complete transformation which is going on the industry side. When we talk on technology, when we talk of the business model innovations, there is a lot of collaboration between the digital and the energy platforms, since they go hand in hand and both are really dependent onto one another. So when we talk of digital platforms, we have the IT, of course, which is a major part, and also the OT, which is the operational technology. On the energy platform front, we have people, technology, and services. So this is where there's a close collaboration of both these platforms, and I think that's also one of the reasons that I'm here discussing this topic with you. And when we say the different segments, it could be from the energy, the utility, the industry, mobility, smart life, IT, and so on. And there is a data center optimization that we talk about. So there's a lot of data and the solution which would go hand in hand between the end user and the complete, I would say, the complete digital and the energy platform. So there's this complete data interface which forms the crux of these life solutions, working fine, working in a very sustainable and a secure manner. All right. And then if you see the pioneering of the digital grid, there are core automation, digital technologies. So these are terminologies which, of course, all of you will be well aware of on what's the OT, how do we go about the automation. So it's very interesting that, once you have such sophisticated electrical equipments, control equipments throughout your organization, throughout the energy portfolio, what standards they are based on, what is the kind of control mechanism that we have, and how the automation actually takes place, where you have large electrical equipments on the field, and you have a person who's sitting in the SCADA or the control room, and how actually the things are being done. So that's again an important aspect. And if you see the different functions, the major functions which is very important from the IoT or the digitalization point of view, of course, the first one is the viewing and analyzing operation and asset data by multiple stakeholder and experts. So this is something which is very, very important, because you may have good IT solutions available, but the way it is really applied to the end user becomes very important. So as in, you would have to identify the different assets, and there is so much scope of digitization or IoT that I would say is presently undergoing for all the major sectors to be implemented, that we have a long way to go. Of course, we have got made good progress, but again, there's a long way to go here. And also, it is being combined with lot of other data. So it's not only the conventional values that you would look about, that okay, what's the megawatt, what's the reactor power, what is the power factor. Hope I'm not, as an industry, I'm not exceeding the contract kVA demand, there's no penalty and things are running fine. It goes much more than that. You would now have weather, you would have market, user requirement, demands, etc. So when you sit in the control room, you are working in a load dispatch center, you would also have to take into account that now there would be renewable sources which are going to be present in your system. So what's the weather forecast that we have, what's going to be the market condition, what is those tariff guidelines which I would have to face. And when we talk of weather forecasting, this is again one field where a lot of work is being going on, and in alignment with the meteorological data, still there is an accuracy of almost 15 to 20%, which we have, an error of 15 to 20%, which is still there. So there are a lot of, I would say, startups, there are a lot of companies which are working in this area in order to make this weather forecasting more and more accurate. So once we have this, things will be better for, handling the complete system and the energy security aspects. And then using the digital technologies. So, sometimes you may visit a control center, and of course, I have done that. I have had a lot of technical conversations with many important stakeholders, and many times there's an apprehension that there are advanced software solutions which are available, but people are really not very confident to utilize it. So, using those digital technologies is also very important, and that would happen that once we are, really able to benchmark, we are really able to present forward a case that, look here, there is an application of digitization, there's an application of artificial intelligence, of big data, which really makes sense and which is going to help you make expert decisions. So that is also one area where we need to move ahead with confidence and further improve the asset operation performance. This, of course, goes back to defining your KPIs, where, the moment we enter with the system, it is asked that what's those key performance parameters that you would meet once we have these digitization policies implemented. So that's again important. Then improving the asset and operation performance. So here, you could have different measurement parameters like the productivity, the reliability, the quality, the safety, the security in different terms. And then, of course, application of virtual augmented reality, the software defined machines, the AI, machine learning, time sensitive networking. Since what's that time synchronization again, because they could be a relay which you have in Faridabad, there could be a relay which is there in Gandhinagar, and what is that exact time synchronization that you see. So if, for example, there's a command to be given, then the time synchronization has to be done very quickly. So it has to be a time sensitive network where you're trying to control what is the kind of selectivity, what is that kind of sensitivity that you would like to have in your system. So that again becomes important. Then, of course, big data, which is the cream, or we are really trying to accumulate all the data that we have. The more data from field we have, the more aware decisions we would be able to take. Then the inexpensive computing, of course, this is because we are not taking risk with the live systems. We are trying to do modeling, we are trying to do simulations and test in our system that what things could go wrong or what's the best way to go ahead before implementing it on the field. Cloud computing, cybersecurity, the connectivity, blockchain. Blockchain is, of course, it may be an area very relevant for all of you in the R&D world. But as far as the power value chain is concerned, this is comparatively new. And we are really trying to see that what could be the typical applications and how we really try to make it feasible as far as the blockchain application is concerned. Okay. And then, the complete energy security aspect that we have, it talks of the same energy that we have, but managing it much better. So, we are trying to unite the real time forecasting that we have into the system as well as the historical data. And ultimately, we are trying to deliver the operational efficiencies in the system. So, this is a small example of a office setup. So, you see, there is an office building, you have a rooftop solar, at the same time there is an e-mesh power store. So that is a kind of container which is shown by a arrow. It is somewhere near the shed sort of thing in the office. So it would be typically a container which also has a battery and which will try to control the complete thing, that what is that particular time you would like to have solar as a power source, when do you want to use the battery, or what time you would rely on the incomer electricity supply. So those different things. And of course, then you have parking facilities. So friends, maybe in all the academic institutes, as we see more and more e-vehicles into the system, you could see that in your parking, typically in academic institutes, in townships, in hostels, you may see the parking coming up with an EV charging infrastructure. And while the faculty park their vehicles in these places, the vehicles would get charged. So there are a lot of business models also which are being worked upon in this particular area. And then when we talk of a typical campus, what are those different kind of data? So you have the load data. Load is basically the end user equipment, the grid data, market data, weather data, and so on. And then you have different platforms. So Lumada, of course, is one typical name specific to a company. And then you have an hourly, daily, weekly load profile. And when we say data, it really becomes very important because it's not a steady state one. And if we typically look into the Indian system, we would have our own load cycles. It would be completely different from USA, which is a cold country. There are a lot of heaters which way they utilize. In our case, the load cycle is different. We have good 3 to 4 different seasons, and also throughout the day, the loading cycle is different. Where if you talk of the different customer segments, so you would have residential, you would have commercial, and then you would have industrial as well. So the kind of usage would be very different. And also in India, there are a lot of festivals also which impact this complete energy security aspect. So say typically, Uttarayan for Gujarat will be very different, and for Maharashtra, Ganesh Chaturthi could be something very different. So, those are the kind of aspects which we need to incorporate, that too on an hourly, daily, weekly load profile, etc. And there is a lot of optimization that goes behind such solutions, where we are trying to maximize the renewable sources available, the economic benefit available, as well as try to minimize the losses in the system. So this again becomes very interesting. And also there are asset performance data which is really applied on the field. And then at times you see a network which is reconfigured, you try to redistribute the loads. So you have a lot of algorithms in the IT system which work in background. So this is how the live decisions are also being taken, where as engineers, as experts, we define that these are our priorities, and the decision making would be based on this logics, and they actually get implemented for actions to be taken in the field. Where you say a particular network, it could be reconfigured and the loads would be redistributed in order to have a more secure system. And at the same time, scheduling is a very important part. So like if you are an industry, or if you are a power plant producer, you would have to define today that what you are going to consume or generate tomorrow. So based on that, there's a complete mechanism of scheduling and power management that goes behind this complete system. So that again is very interesting. And of course the alerts. So if you see a very small alert given here, asset performance alert, possible failure in 4 weeks due to part deterioration. So you see an alert that a particular equipment it's getting overloaded, and there could be a failure in say 4 weeks. And what is the recommendations once we are talking of any electrical equipment? It's not really immediate replacement, that okay, there could be a possible failure, let's just replace it's not possible to immediately do it, because you have to arrange the other things, you have to take your power backup and then really change over the systems. So there's a simple recommendation of reducing load until issue is addressed. So there is a load minimization, there is a load shedding mechanism which could be put into place so that the present load is reduced and the asset failure is, we are trying to balance it a little better, or we are trying to give it a little bit more time till we have the alternate solution in place. So this is how the right decisions are made, and more importantly they are made faster when you are trying to apply the IT aspects and the big data aspects typically. All right. And then this, of course, is a typical example of e-mobility also. So here you see e-buses being shown. So if you come to Delhi, there are a lot of electrical buses that you would see into the system. So here also you have various categories of data that you have. So it could be a dispatch schedule, a fleet routing data, a vehicle battery status, the sensors data, the optimal charging schedule, and so on. And why this becomes important is that unlike the conventional buses, these would rely on electricity to get charged. So the number of buses, say in a municipal corporation, would have a schedule that there are 50 buses coming in a day. So what particular time they would come? What is the schedule of those buses? So if you are aware, for trains there is already a e-traction system which is there. Similarly, for buses also we would have more and more electrified transportation, and that's where you would have the fleet routing. So a group of buses which you have, what is the kind of sensors, what is the charging schedule, so at what time what group of buses would be able to charge at a particular EV point. This has to be very carefully thought upon. Of course, the battery status of the vehicle and many such other data, the traffic, the weather conditions which go in background, this again impacts the complete functioning. So if you see the electrified depot and the depot functions, we see the grid connection, the charging station, and the battery storage. These are multiply related to the depot functions like the concurrent charging, the charge needed based on dispatched route, the condition monitoring, load monitoring, maintenance, etc. So once you have, if you see Ahmedabad, it's a real busy route. So when you have a number of buses, this again would give you so much of data and so much of important decisions which are to be made based on this data, that this again is a very important application where you could also hear of wireless systems, you could hear of connectivity with digital enterprise and so on. In fact, there is also work going on few magnetic roads or some wireless charging where the vehicle gets charged even without connecting a charger. And of course it's more of a tug of war when we talk of e-mobility on whether the manufacturers are coming up with it or not, whether as a technology you have the EV charging infrastructure in place or not, and what are the government policies or the subsidies that would go behind it. So that again is another interesting area. And when we talk of a smart grid, when we talk of a digitized grid, the major approaches which are there is, of course, first it has to be stronger. And when we say stronger, it has to have an optimal power quality, a low opex, yeah, that means low operational expenditure, a higher resilience against the physical and the cyber threats. And at the same time, when we talk of resilience, there should be no performance degradation that we see into the system. We transport more and more renewable electricity and with less losses and less capex, which is the capital expenditure. So that's where we are trying to make all the systems stronger and have all the cyber threat aspects being covered. We are talking of smarter systems where there are safer, faster installations. They could be readily reconfigured, upgraded, and of course, prediction of the assets on when they will fail. How do we have fewer outages in the system and so on? And of course, the improved coordination, the greener aspect where we are trying to have more of renewables into the system and saving lot of carbon emissions that we are trying to place into the system. And if I talk of few microgrids or a renewable energy integration, the kind of segments and the typical customers that you see. So if you see, there is an segment also which is related to defense. So those are the governmental defense institutes. You see institutes and campuses, the education institutes, and then of course the different industries, residential, research centers, islands, and so on. So when we try to go about a technology which would be applied to a particular segment, there is a very important consideration that goes behind it. What are the kind of drivers that we see behind it? So in case of defense, you have to have the economic, the environment, the fuel disturbance, and the uninterrupted supply. So uninterrupted supply is a very important aspect, and when you see uninterrupted supply as a tick mark, you would like to see that what's your present electrical system, what's your present source, and what are those kind of backups that you would like to have into your system. So a data center, a parliament, a hospital would of course have more redundancy aspects as compared to a normal, say, a commercial place or a residential place, and so on. And we'll briefly talk on e-mobility. So e-mobility is basically more of electric vehicles, and if you see, there's a lot of anxiety that we see around everywhere, where even we have typically termed it as range anxiety, where you are trying to see that what's the kind of mileage your electric vehicle is going to give, the charge anxiety, the energy anxiety, where we are trying to see that what is there really a EV charging infrastructure available around me, and the energy anxiety, where we are trying to see how much time would it take for my car to get charged, what's the kind of charges that I would have to pay. And when we talk of all these anxieties, it's going to be the big data analysis which would form the backbone and which would answer all these questions. So I hope that that was interesting, and we take a few more examples as we go ahead. And then asset management. So when we talk of asset management, um, I would like, for the benefit of the participants, there are times when you hear that a particular transformer it got burnt out, or there was a fire in this particular building, and so on. So that's where the fact lies, that when we talk of India, the present utilities, the present segments, they have been in operation since long. So, say for example, they could be 50 years old, they could be 60 years old, and we have those equipments which are getting overloaded. But do we really have an account of what the present loading is? Or, say for example, in your institute or your society, your surrounding, when was the transformer being put up? What is the next time this transformer has to be changed? Because when we typically do design engineering, we begin with the technical specifications, and there is a design life for all the equipments. So say typically it could be 20 years, 30 years, where you try to define the major electrical equipments and a typical life cycle, and based on that the manufacturer would supply those equipments. So when we talk of these existing data which is available, so there are one or two utilities which have really digitized themselves, which are very up to date. But again, there's a lot of work that we are doing into asset management, where we have an application of IT and OT in the power towards the digital transformation, improving the processes, the people, and the technologies. And what basically we are trying to capture here is that even if you need to know what's the present status of the equipment. And at the same time, there is a tendency to overload the equipments, mostly because there is the budget approvals or something, where you always say that if something is running fine, let it run fine, we'll see next year. So that is, of course, when we say asset management, it is not a simple decision that the design life is 25 years, at the 26th year I would replace it. It's not that. It lies a much more aspects, a much more analysis, where you would really see that whatever equipments are there, what is the present health of that asset. What is they could be, there are large power transformers which really, if they work fine, they really don't need an replacement. But there are so many tests that you could have. You could have DGA, dissolved gas analysis, you can have different tan delta tests on a transformer, and you can ascertain that what is the kind of health of this transformer. So there could be few which are very healthy, you could go on with that. There could be few which are alarming, and few which are critical, which is the very important objective behind applying this IT and OT into the asset management aspects. So, if you see, there could be a short term goal where you want to have a clarity on maintenance actions, a medium term where you could have a fund which is being allocated, and a long term, which is most important, where the top management would plan their investments over the 20-30 years. And ultimately you are trying to ascertain what is that asset reliability and availability that is being promised. So if you see that, even starting from the baby steps to the giant leaps, this is something which is going to completely revolutionize the kind of site installations that we have. And as I was saying, when the algorithms are being defined, there are different parameters, of course, the risk, the cost, and the performance. So, a very strategic and a systematic approach to manage the assets and to take decisions which are better and which are based on these information, the kind of big data that we have into the system, and so on. And then when we talk of performing this asset management, it's important that as say as a site person, I may have a lot of data. As an IT solution provider, you may have sophisticated softwares, algorithms which could do the things. But how do we really bring into a practical implementation field? There have to be major drivers behind it. So, of course, one of them is policy driven, then the performance based, the evaluation of the different aspects where the life cycle value realization we are trying to do, the data driven, which is important because with the Singapore example that I was mentioning, it's very important that when you are looking for measurements at say 500 points, what is that data that you would like to measure, how it is being collected. So once a person goes with the measurement kit, then what is that particular data that we want, how do you make the connections, what is the format in which it is collected. Because typically when we do any research work, you would start with a particular set of data, and then you go with the data cleaning aspects, and then identifying the bad data, removing it, and so on. So similarly on field also, it's the same process, but the kind of dump that we could have, it could be stupendous. So that's where, to control it, it's very important that we define how the connections are being made, what is the exact data that we would like to have, what is that format where it is stored, and who would have access to it. So even that IP or data confidentiality again is very, very important. And especially the advanced countries, they are very careful with the data and the passing on of it. So that's where we are, it's a data driven approach where you're trying to see that what is the data that you are having, and of course the quality data. So once you really have that dump of data, but it's all about that data crunching or say useful data which would support the decision making for any particular application. And then of course transparency, where it is a decision making which would be based on data management principles and achieve the overall targets, because sometimes it is there are some miscellaneous logics which are put behind, but if you have anything digitized, then the things really go based on the organization mission that is defined. And of course the financial operational transparencies is again important, and the safety aspects which go behind such things. And if you see the convergence of planning and operations, we see a graph where things begin from static data to a near real time and a real time data. So real time data is the peak of the business transformation which we are trying to work upon, where moving from a reactive approach to a proactive to a predictive, we are moving towards a prescriptive stage where the different smart meter, the voltage, the VAR analytics, the grid analytics, the kind of outages, the risk management, the storm impact, demand, operational planning, capital planning. So you're trying to mix all the available field data, the technology, the different aspects, the neutrality, sustainability aspects, and of course the commercial economic aspects also into your system. So when the conversion takes place, the transformation into a digitized system would incorporate all these important aspects into your system. And of course, these are some of the questions which come up whenever any asset management or digitization journey is started. And it becomes important because we are talking of big data, we are talking of exploring these things. And this, I think, is really interesting because this is the way it is actually done on the field in the industries, where how do you start, what is the maturity index you would like to look into. A greenfield solution where you have a new project and it's comparatively very easier to design your specifications and to have the solutions accordingly. And then the brownfield solutions, which are a bit typical because you have the project or say the facility already in place and you are trying to add these digitization aspects into them. So that's where, and identifying the right data. And once we go to a live system, this really is a brainstorming exercise where of course keeping the end goal in mind, there's a lot of deliberation which is put into what's the kind of data we would like to have, what is the actual KPI, and is the asset management or digitization just a software? So which is not the case, because whatever solutions we are trying to put forward, they are not just softwares, they are not just big data, but they are a complete solution which would make better decisions and really enhance the kind of energy security that we are talking about. And the different tangible benefits, the costs, domain expertise, continuous evolving, improving safety, and so on. Because once we define this system, again every few years and at every periodic time, we have to keep revising these solutions that we put up. So that again is an important part, and this would be a typical phased approach for asset management, where as a first step you're trying to create the foundation knowledge. Then we are moving towards assessing what's the present maturity level, what is the plan to be developed, what is the improvement program, and so on. So of course we could go into detail of each of these, but just in a nutshell, it's not the strongest species that survive, nor the most intelligent, but the one most responsive to change. So that complete transition is around. And the more carefully we are trying to incorporate this big data, the more better it would help us make better decisions and enhance the cybersecurity aspects. And this is a small example, which of course is related to a risk profiling, where a circuit breaker, which is a connecting element, if it fails, what is the failure, how, what's the time being taken, how do you isolate, and how do you restore the system. So this of course is a typical risk profiling, where it is identifying that what's the low risk, what is the high risk, and what is that critical area where immediately you would have to take action. It's a critical asset management part, and then you would like to move ahead. And now going to the networks of the future, the blockchain and the cyber security. So, being from the IT background, of course, you would all be very well aware of the blockchain technology, where in blockchain you have a transaction with different connected distributed systems. So, there's not a centralized system, but a distributed system where you have sort of blocks, and the information is managed in one to one level. So the central stakeholder figure is not there, but there is a collaboration among the nodes of the system, and there's a peer to peer communication that takes place for the blockchain. And of course, this is a very simple example on how, if we have to make a transaction, it is typically for a representative purpose. This is mentioned as a data block, and the block is transferred at everywhere, the different nodes, wherever it is approved that the transaction is valid, the new block is then added to that chain, and then the transaction gets completed. So this of course is a very basic mechanism of how any information uses a big quantity of computation power, and how a transparent transaction takes place. And if I have to briefly say that what is it related to when we talk of the electricity sector, then the main characteristics, which of course is applicable to all other sectors as well, is that we are trying to make the system more secure, transparent, without intermediaries, and have all the aspects of these three D's: digitization, decentralization, decarbonization. These are very important aspects which we are trying to discuss everywhere whenever we talk of new technologies and so on. And in fact, there was an EMA conference on net zero, for which I was the session chair last month in October end. And there from Siemens we had a expert, and very interestingly he said that we have these three D's, and now let us just focus on the fourth D, which is do it, just do it. So that's where you will always hear this digitization, decentralization, and decarbonization, for which really adds relevance for the energy sector, and especially because there is an ongoing transition that we have into the system. And then of course it's very interesting that although you may work into the IT sectors, but what are those typical applications you would like to see? So there is the electricity market that you have transactions, you have flexibility, you have managing of data, EV smart charging. So typically you had meters, you have prepaid meters. So going down in a few years, you may be you may have that power of having options, like you have the option of SIM card today, that I would like to buy power from here, there, and that's how even the states have opened up purchasing power from each other. There is also the concept of one solar, one grid, which is going on in the initial stage, where we are trying to say that the sun is going to be at some place throughout the world on the peak, so we are trying to capture that. And India is a pioneer, and even in the International Solar Alliance it is being appreciated a lot, where even UK and USA have joined this agreement. And through this belt we will try to see that there are these inter-country transactions also. So there also I see an interesting application of blockchain for measuring the same. And Then, of course, there are other applications like the equipment, the people certification, the funding, workforce management, and so on, which could also be an interesting application. I'll just take a break for 5 minutes if that's okay. Uh,
Yes, ma'am.
yeah, okay. I'll just take a break of 5 minutes and
Sure, sure.
yeah, thanks. Okay, so I think we can resume now.
Sure, madam.
Yes. Okay, so while we were talking of blockchain, as I had mentioned that this is comparatively a new technology, and we are really trying to see that is it really that effective, and will it really change the world, or there are these challenges which will make it not as successful as it appears today. So if you see that the applications could have different aspects like the risk of centralization, the stability, energy cost, the interoperability, acceptation, regulatory frame absence, etc. So these are the challenges that we presently see. And as far as the electricity sector is concerned, we are trying to establish the application of blockchain into the system, where it has to a long way to go. So there is again, if you see the different advantages that you see, there are also certain challenges where at one place it is mentioned it is slow compared to the centralized database. That's where we see a question for its large scale applicability. Again, it would offer saving in the transaction cost and time, but what about the high initial costs and the capital? It could be an obstacle that we see. And of course, each transaction, it would again have a high electricity consumption. So it's interesting that when we talk of these IT applications, they are closely related to the electricity or the energy segment. Of course, then when we talk of interoperability, presently there's a lack of standards, and there are some limits where the collaboration capacity is concerned. Then of course all the other, which I think regulatory frame absence is very explanatory, where before the implementation we are always waiting for very clear guidelines from the government, as in what could be the correct jurisdiction choice, what about the data privacy factors, and so on. So once you talk of large scale applications, these are the factors which become really very important. And what is the process, what's the participants, what's going to be the jurisdiction, and how do we go about it, again is going to be very important. And then I have also tried to briefly touch upon on what are the advanced enterprise software solutions. So when we talk of digital transformation, there is also a lot of advanced softwares that we have in place. So as I was saying, from field to the boardroom. So you have the field, then the control room, the operation centers, the boardroom, and so on. So we are talking of a system which a digitalization transformation solution, where we are beginning from milliseconds and going to years and the future. So this is how the complete big data is going to play a very important role in the kind of present and the future predictions that we have. And of course, then each of the segment in terms of the field devices, the network control, the asset management, the workforce management, the energy portfolio management, and so on. So that's completely where the ball game is going to change, and we will have faster decisions which will be based on the insights which we gain starting from milliseconds to the different years and the futuristic aspects. Then of course a network manager, which again is very important, where these are of course very specific applications when we talk of different data models, the simulation mode, the case study, the SCADA communications, external adapters, data exchange, and of course the DER communications. So DER is the distributed energy resources. So once you see that you have a microgrid, a solar rooftop, the kind of data that they bring in, and there would be a two-way data, because as a building you would previously only be taking power, but now you're also giving power back. You are trying to put back into the grid whatever excess amount of power you have generated. So that again, the bi-directional flow of electricity and data is again very important. And this is a typical example of a network manager, where you can see a real a map where the different locations are being seen at the same time, the same as a model in an electrical network format. So what is that user interface that goes behind it? What is the SCADA functions, starting from the data acquisition to the alarming to calculations, integrated data engineering, historians, then moving to the outage managements, where you have a prediction, you have a maintenance operations, you have switch order management, then the applications, where you have the state estimation, the predictive load flows, the restoration facilities, and so on. Then of course the forecasting, the optimization, the optimal power flow features, and so on. So that's where a complete training simulator also goes behind. And there is also a prognostic feature which we are working on which again gives us an example of when do we reach a critical condition, when do we expect a malfunction, when do you get an alert, and what if we change the load. So once we do it in the back end in simulation, it appears very easy, but when we really apply it to the site, it becomes really very interesting. And that's how models mature. This is a very quick view of how the critical status would occur. This is, of course, of a typical product Eclipse, where it is showing what are the different asset risk zones by type, whether it's a low voltage, medium, high voltage, what's the kind of equipment that we are talking about. Is it a battery, a circuit breaker, or a switch, and so on. And then, of course, this is an example of advanced simulation tool, which is Niplan is the software, and the e-mobility studies are done. And typically, there's a lot of big data that goes inside it. So you could have a duration curve, you could have a load curve, that on a daily basis, on a monthly basis, what's the kind of load that you see into the system, and what kind of analysis you would like to come so it's typically a stochastic, a time based analysis, where you have a lot of input big data. You are trying to process it through the hosting capacity, the technical simulation programs, and then you try to see that what is the kind of benchmark, what is the multiple scenarios. So it's not defined in a particular manner, but the load could be different, the generation could be different, the amount of conventional or renewable that you are adding into the system. You could have real stupendous amount of simulations into your system. And also there is a GIS representation, which would again predict that what's the penetration scenarios of these different technologies. And also we are talking a lot of green hydrogen. So if you are aware, in April, India defined its hydrogen policy, and it is being said by Amitabh Kant, who is the CEO of Niti Aayog, which Niti Aayog is a kind of national think tank that we know, and it works on different technologies. So this is one area where instead of the sunset, in the sunrise sector, we are trying to target its application. So this again would have a lot of background big data, the digitization aspects, and then of course the different approaches that you have. And this again is interesting because when we talk of hydrogen and a hydrogen power enabled smart grid, you would see a lot of data flow in the system. If you see the circular D, that is a data. So wherever you have a renewable energy provider, it would interact with the monitoring and forecast. Similarly for the hydrogen producer, similarly for the end user, the city, the office, etc. So you see the data flow is getting everywhere. So this is where the multi-resource platform and the big data handling transmission is being discussed. And if you talk of a typical data center, so data center is a very typical application. And of course, even after COVID, we see a lot of new online services. We see data center are getting more and more integrated. You talk of website hosting, you talk of financial services, forecast models, it is everywhere. So and if you see the data center or the computing clusters, they have a very very unique power requirement. So you would be looking for a very very high reliability, you want a high power quality, and at the same time you also have to use renewables and make it cost effective. You want to implement more of green technologies and so on. So there are these grid edge solutions which are available, which would capture typically microgrid, fuel cell, battery, etc., where again uh, if I directly come to the redundancy levels, so there could be in the normal systems you have n. So say for example, if you require a particular amount of energy or power into your system, that is the kind of source you would have. Let it be a generator or let it be an incoming power supply, and then you could have n plus 1, where if something goes wrong, I have an equal amount of another alternate power source available. But when we talk of data centers, we are talking of tier 4, where you have 2 into n plus 1. So you would have a most reliable topology where you have two active feeders already there into the system, as well as a redundant UPS and a genset. So say you would have a diesel generator, you would have a UPS which is in addition to the two existing active power sources. So this is the kind of redundancy that we are talking of as far as the data center is concerned. And of course these are the different design, the different options which are available, and how do you go about having a comprehensive techno-economic consideration and having the different aspects like the feasibility, the design engineering, technology, outcomes, optimization, and so on. And then, of course, I would like to briefly present an example of how the big data application is there. So this is a application where we are trying to see that how does the big data actually impact, and these are the CERC guidelines, where on the complete power handling you have well defined goals by the Central Electricity Regulatory Commission, and how the different deviations, the power, the additional charges are to be handled. And if you see on the right side, the renewables from 8, they will go to 18% and then greater than 20% by 2032. So this again is an ambitious opportunity, but with lot of responsibility, where we have this big data and how do we handle it. Then of course these are the test models. One is the IEEE standard system, the second is the Gujarat real time, and the third is for renewable. And these are, of course, advanced power system softwares where the different power flows are being done. The complete calculation it is done in Excel, and then for the test model, which is done by a data mining approach, what are the parameters to be targeted? What are those parameters for the C test model? And around 50,000 time blocks data are being analyzed here. And presently, if you know, there is a data block of 15 minutes. So throughout the day, every 15 minutes, this power data is being aggregated. And there are discussions going on that this should be made to 5 minutes. So if you see, this 50,000 could easily mean 1,50,000, but this also for a particular duration. So this is the kind of data that we are talking about, and capturing the progressive digitization and IoT that we have into the system. And Vika is a tool being utilized. And then this is the complete data mining knowledge flow, where you have your basic architecture, where you define the data source, the attributes, you create validation folds, you have an algorithm for decision table, then you have a performance evaluator, and finally it would go to the performance results as well as the plot visualizations. And this of course is the strategic categorization of what year data had to be targeted and with what descriptions. So for example, 2016, 2050, 2012, as there was this grid disturbance over there, and whenever the regulations were being revised, the trends of those particular years. So if you see the load pattern variations, and this of course was again matched with the kind of report that is being issued by officially on what was these rate change, how is the deviation settlement mechanism working on the renewables, etc. So this of course is a flat curve, which is the guideline. Then if you go based on statistic analysis, this is the Excel based, where you're trying to see the min, max, and the average value. But once you have the data mining, the application into the system, you are really able to get that complete envelope. You are able to get certain bad data, and of course, this when you relate it to the practical industrial experience, there are events, there are occurrences which give a very clear view of the complete system without uh, having to go through tedious Excel calculations and a data filtering. So that's where, even for the renewables, there are certain parameters which are there. So that's where, in a nutshell, I would say that the big data applications for energy security, this is really a boom area. As industries, we are trying a lot to, work into this area. The feedback is very good, but the more and more pioneer we become in this area, we would like to have more startups, more research projects from your end, so that the cyber, the energy, the security, the IT, big data, artificial intelligence, and machine learning, which, I think collaborating, we could really make things a lot better, secure, and greener. So that was a brief from my end. And of course, if there are any questions or you would like to discuss more on anything, we can, of course, go ahead with it.
So, any participants wants to ask anything, can please ask or can write in chat box as well. But anyways, the session was really very nice, ma'am. We got the practical exposure also, and we hope that in our upcoming FDPs we have more and more this type of sessions, because most of the time we come where experts come from the university and those things, which is also important, but getting industrial exposure, this type of session really helps us also.
Thank you, Jugal, and thank you, Prakash Meena. Yeah, I just wanted to highlight that, I'm also closely connected to academia. So I'm a DPC member, and I regularly try to get back to the institutes, because it's very important that whatever, research work and etc. we are doing, one is we try to understand the practical aspect, and secondly, do something which is more related to industry problems. And even when we take we have recruitment drives, we try to have students which are a bit updated with the practical part. So thank you so
Yeah,
much. Yeah,
yeah, ma'am. If any question comes, I will anyways forward to you. Thank you once again.
yeah, thanks a lot. It was a
Okay.
pleasure. Yeah, thank
Yeah.
you. Thank
Okay.
you to all participants. I hope you are awake. After lunch, it is a real challenge.
Yeah, yeah, that's true. Because nowadays what happens, offline and online, both started. So people are not getting involved in online things. They are engaged in offline things. So that is becoming challenging. Right now, hybrid thing is going on.
Correct.
So even it's difficult for us to pull the crowd.
I agree. In fact, I did have some sessions in NPTI, which is National Power Training Institute. So there, we had a program sponsored by Ministry of External Affairs, and we had global participants from different time zones, almost 45 of them. So
Wow.
then we tried to see that, at some time or at least at the end, we have their cameras on. So it was very interesting and interactive, and I think that's the way we can connect better. So maybe some other time. We may see each other
Yeah.
physically as well. Yeah.
Sure, sure, ma'am. Sure, ma'am. Okay.
Okay. I have to join another meeting. Jugal, it's okay if I may switch
Sure,
on.
ma'am. Sure. Thank you
Okay.
so
Thanks
much.
a lot. Thank
Yeah.
you. Bye.
Di- Dear participant, we will see you tomorrow morning again at 9:45. Tomorrow is our last day, and post lecture will be having feedback session and exam also. So please be online at that time, and please participate in the exam, because only if you are qualifying the exam you will get the certificate. Thank you so much. See you again tomorrow. So tomorrow exam will be at I guess it will start at 3 or 2:45. I will anyways intimate in WhatsApp message. So please stay online and just follow the messages which I am going to give on WhatsApp, and even I am going to announce here as well. Thanks for your support. See you tomorrow.